Dun, 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 dun. Animal cell from birth to death. For the formation of the sperm, a process called spermatogenesis occurs. A spermatogonium with two sets of chromosomes, or a diploid spermatogonium, from the male individual undergoes mitosis, forming a diploid primary spermatocyte. This primary spermatocyte undergoes meiosis I, forming two haploid secondary spermatocytes, which contain only one set of chromosomes each. These secondary spermatocytes undergo meiosis II, finally forming haploid spermatids, which mature into spermatozoa.
To recover from a spasm, found myself swimming in some clear cytoplasm.
Or the sperm. Next is the process called oogenesis, wherein the egg cell is formed. A primordial germ cell forms an oogonium, which undergoes mitosis, forming a primary oocyte. This primary oocyte undergoes the first meiotic division, forming a haploid polar body and a haploid secondary oocyte. The secondary oocyte undergoes meiosis II, forming the ovum and a secondary polar body. And that is basically the process of oogenesis.
We're going to talk about early embryogenesis. Say you're an egg cell, and you have this nice thick outer glycoprotein coat called the zona pellucida, and you've got your plasma membrane just inside of that. And a sperm has made its way through the zona pellucida and managed to get in through your plasma membrane and merged its genetic material with yours. You're now called a zygote, and you'd like to go on to form an embryo, but not much is going to happen when you're stuck as a single cell. And so what you've got to do is divide into multiple cells, and you've got to do it fast. In fact, you've got to do it so fast that you don't have time to grow. So you actually just split into two cells, and this process of splitting without growth is called cleavage. And you do this a number of times, dividing from 2 cells to 4, and from 4 cells to 8, all the while staying within the zona pellucida. So you've gone from 16 cells to 32 cells, and at this point you look different enough that somebody decides to give you a new name. So instead of being called a zygote, you're called a morula. And morula is just a Greek word that means mulberry, and you actually do look a little bit like a mulberry. So here's a picture of a mulberry from my front yard to prove it. This one's not quite ripe. So you're finished with the cleavage stage of early embryogenesis. You've gone from 1 cell and just divided without growing at all into 2, 4, 8, 16, and then 32 cells. And now more interesting things start to happen. So you're still stuck within that zona pellucida. So we'll draw it in here. And I'm not going to keep track of the number of cells anymore, I'm just going to draw them in. But what you'll notice is I'm drawing them in quite compacted. I'm drawing them all right in the middle of the structure here. And they do look like they're a little bit tighter together. And this is a process that's called compaction. The different cells within the morula start to get closer and closer together. And in fact, the cells start to get a little bit different from each other too. You notice that these cells on the outside are a little bit different. I'll draw them in here, slightly different color. And we can tell them apart, and this process of being able to tell cells apart as they become different things is called differentiation. So here we have 2 separate populations of cells. This one on the outside, we'll call them trophoblasts, and this mass of cells on the inside we'll call embryoblasts. And so you're going to continue with your process. We'll move on to the next stage. Again, we'll draw our zona pellucida here, and we'll draw all of our trophoblasts along the outside here. Another interesting thing is happening to those cells in the middle. They're starting to clump even more. In fact, they clump so much that they all cluster at one end, leaving a little cavity on the other end. So here you can see your trophoblasts and your embryoblasts, this mass of cells in the middle. Some people actually call that the inner cell mass, and it's left you with this cavity, and that cavity is called a blastocele. Now, again, you're starting to look a little bit more different than you have in the past, so we're going to give you a new name. This structure that you've turned into, with a blastocele and an outer cell ring of trophoblasts is called a blastocyst. In fact, we name this whole process after you, and after cleavage, the process is called blastulation. So also about this stage in blastulation, your zona pellucida starts to disintegrate away. Here I'm going to draw little bites being taken out of it here as it falls away and disintegrates. And that's going to be important later on because you can't be stuck in this thing forever. And the next step in blastulation, you actually just lose it completely. So now we'll draw our trophoblasts completely naked without a zona pellucida. But more interesting things are happening to you. Your inner cell mass of embryoblasts is starting to look a little bit different. So you still have this rim on the outside here up at the end of your blastocyst, and you still have this mass here in the middle. But you've developed another cavity, and this cavity is called the amniotic cavity. And also, your inner cell mass of embryoblasts has started to differentiate more.
To get out of the rain, there was the gatekeeper, the cell membrane. Went into a cell, and what did I see? The mitochondria, the energy factory. I went into a cell and said, "Who drives this bus?" Found myself talking to the boss of the nucleus. I went into a cell to recover from a spasm. Found myself swimming in some clear cytoplasm. I went into a nucleus to ask how to get home. Got genetic info stored in a chromosome. I went into a cell and stretching oh so far. The thin wavy network is called ER. I went into a cell trying not to be perplexed by the packaging and sorting in the Golgi complex. I went into a cell and said, "Who makes proteins here?" And somebody responded, "It's the ribosome, my dear." I went into a cell and was feeling pretty fine. Lysosome engulfed me and dissolved me in enzymes. I went into a cell and was feeling pretty nimble. Centriole lassoed me, tying me up in a spindle. I went into a cell to get out of the rain. There was the gatekeeper, the cell membrane. I went into a cell, and what did I see? The mitochondria, the energy factory. I went into a cell and said, "Who drives this bus?" Found myself talking to the boss of the nucleus. I went into a cell to recover from a spasm. Found myself swimming in some clear cytoplasm. I went into a nucleus to ask how to get home. Got genetic info stored in a chromosome. I went into a cell and stretching oh so far. The thin wavy network is called ER. I went into a cell trying not to be perplexed by the packaging and sorting in the Golgi complex. I went into a cell and said, "Who makes proteins here?" And somebody responded, "It's the ribosome, my dear." I went into a cell and was feeling pretty fine. Lysosome engulfed me and dissolved me in enzymes. I went into a cell and was feeling pretty nimble. Centriole lassoed me, tying me up in a spindle. I went into a cell to get out of the rain. There was the gatekeeper, the cell membrane. I went into a cell.
And after all these magical processes of gametogenesis, fertilization, embryogenesis, and all of those biological processes that make us who we are now. We are eventually born into this magical world as tiny little beings, like every other animal, which are just little tiny copies of what their parents used to be. So, during these early stages in our lives, we undergo rapid physical development. We burn lots of nutrients for energy. So after this, during our middle childhood, our growth rate slowly diminishes. We eventually reach another point and peak in our lives called adolescence. Some animals, such as these guys, also undergo a similar process, but not to similar extents, but you get the idea. Then eventually after this, we revert back to the slowly diminishing process of growing to adulthood, and once we reach adulthood, we stop growing, and eventually we just become living beings who eventually deteriorate and die. But death is not the end of life, for our bodies will eventually decay into nutrients that will sprout new life that will help further generations prosper. So think about it, death is not so bad at all.
There was the gatekeeper, the cell membrane, went into a cell, and what did I